Good afternoon here from a nice and sunny South Africa. We are still in lockdown and still in level 3, and so from around the world, we've got lots of people from various parts of the world dialing in. Thanks for taking the time to spend this afternoon with us. So, yep, we're in the middle of this Smart Focus webinar series. It's now 11-week webinar series that we're actively involved with yet, and doing quite a lot of upskilling and cross-skilling, between ourselves and our clients, and really learning how to run the assets faster and and greener and longer and safer in this VUCA period that we're in. So we're experiencing quite a lot of uncertainty currently in the markets out there. So there's a lot of requirements from our clients, to work more remotely, less eyes and ears on the site, work with data remotely, but it must be secure, work more agile. So being able to basically, drop or raise production quite fast and, be based on demands from the clients. There is a constant focus on energy reduction and, focusing on sustainability. How do we run it more energy efficient and so forth? Linking, the edge to the cloud and bringing that information through, and also, basically linking to separate sites, because various sites, and how do I bring the data into the cloud and enable and use like more data analytics and cloud computing and AI in this specific space. So, lots of focus there. And then there is a requirement for more collaboration between many parties, between the vendors, the system integrators, the solution providers, the various OEMs on site, and the customers. And so, they're looking for ways, and digital, where we are playing, is the best place where we can do this collaboration. And also the requirement for more remote or of measures, and really effectively look at that. So yeah, so I brought this events that we've gone through already. But the key focus is, the themes that we're doing in these events is like trying to bring benefits to our mining and manufacturing customers. So, how to, bring in solutions on how to make the workforce and operations safer, and things like, what we're talking about today, APM and automation helps with, for example, that, or how to operations more energy efficient, more greener, and again, like, so we've had multiple sessions on advanced process control and APM already today. Again, automation, energy efficiency talks towards that, and many others as well. Also, longer and faster is key themes, and you can see sort of the type of savings that we can bring average to the market, sometimes less, but again, it amounts to huge amount of money. So again, faster is things like, deploying or MES, to bring improve the yield, or APC could also help to do the yield. And so there's various things, and in these workshops that we've done with you, or webinars through the last few weeks, if we're covering quite a lot of these specific points. If we go to this slide here, which shows you a little bit of an overview of the operational technologies group that we have at 4Sight. The key message here is that, firstly, if you take technology and you bring intelligent data, and you add technology, intelligent technologies to it, and you focus on the demands of clients and users, then you can come up with new business models that can really bring quite a lot of value to them, and so that enables this, what we call an intelligent enterprise, or enterprise 5.0. And so the type of technologies that we are bringing to you as a group is things like industrial IoT, more at the bottom at the automation layer, or AI and machine learning, deep learning, or advanced analytics tools, multivariate analysis, simulation, planning and scheduling. So through the whole 11-week webinar series, we've been dealing with quite a lot of these technology sets, and been talking to you about that, and sharing some of that with you. Virtual reality, augmented reality, all in interfacing to the SAP, the ERP environments. And then, so if you focused on asset automation, and they are a multi-vendor player. They work with all the big vendors like Schneider, Siemens, Rockwell, ABB, and they do they do plant automation. So they install instrumentation, connect to it, do control, do the associated safety and visualization, and feed the data into that next layer, into the historian layer. And that's where basically BluESP picks up these type of technologies. And so if you look at BluESP, we're more an asset optimization entity, and we focus a lot on basically taking that data, or what we call big data, and transforming the data into information, adding knowledge or gaining knowledge, and turning it into wisdom and ultimately intelligence further. So more about us a little bit later. And then the third party is we also have a group, Simulation Engineering Technologies, about 25 industrial engineers out of Johannesburg also, that focus quite a lot, on constraint simulation in mining and industries and warehousing and warehouse slotting and all these type of things. And also they focus also on like optimization and simulation of planning and scheduling and the control of that. And so they also basically help us to build a digital twin on specific process area or assets or plant areas, and help us to debottleneck and then show us where to apply these special technologies. If we go to just a last quick look before we start with the webinar, if we look at BluESP in the spectrum, so what are we? So we see ourselves as very much an agile, dynamic, multidiscipline engineering company or solution provider, of mechanical engineers and electrical and data scientists and chemical engineers, and so quite a few different aspects. We're an Aspentech reseller and integration solution provider. We use Aspentech as really our role models. We learn from them. We take their very, very intelligent technologies. Like, for example, they're evolving quite a lot right now with bringing embedded AI and machine learning and deep learning into the software sets that we've been doing for quite a while for them in the MES space or in the advanced process control space, or now very much in the APM we're going to focus on today. So we basically focus a lot on that. And then if you look at the sets of tools, so firstly, Aspentech brings us a set of design tools, and it's all to do with how do I design a plant, and also cost it and build it, because if I was going to build something new right now, I want to build the most sustainable, most energy efficiency in the shortest time and at the most optimum cost. And all the software sets there focuses on that, and the EPCs uses that quite a lot. Then we have a whole host of operators. So if I've built the plant or the process, how do I operate it to the optimum? And there again, we have also a set of technologies which, like historian, pull the big data, aggregate it, or MES systems, basically do the enterprise reporting associated with it, delay accounting or metal accounting, mass balancing, all those things, delay, downtime systems, and so forth. So in the operating sphere, and there was quite a few. Next week we're doing again, for the next 2 weeks, we're doing more talks just specifically on MES and elaborating on more advanced features in the MES suite that we offer. And then the third one, which is the focus of today, is really how do we, if we, we've designed it, and we're now running it, and we're trying to push it as hard as possible. How do we make sure that it runs as long and as solid and as predictable as possible? And that's where we get into the asset performance management suite. So the topic of today is machine learning, Mtell, and using machine learning to do predictive and prescriptive maintenance. So predict and prevent assets from failing, and we'll hear a lot about that. But also we've had sessions already in the series about also predicting and preventing process quality failures or variances, and so some of the clients is bringing those type of solutions to us as well, or simulating, and you'll hear a bit about that today also, what is the maintenance risk environment associated with a specific plant, and where is the hot spots that we need attention. So enough of introductory. Let me hand over now to Ganesh to tell us a little bit about himself and introduce the speakers for today. Ganesh, over to you.
Hello, everyone. Thank you, Willem. Can you hear me?
Yes.
Okay, great. So thank you, everyone, for joining our webinar today on condition monitoring with AspenMtell. Before we begin, I'll do a round of introductions for our webinar presenters. And I'll start with myself. So my name is Kinesh Wanachalan, and I'm a APM engineer at BlueSP. I'm a mechanical engineer by profession, and I began my career as a data analyst for Deloitte a couple of years ago, where I worked on large-scale data migrations, mainly in the banking sector. I also had a short stint as a design engineer in the petrochemical industry while working for an EPCM consulting house. And then in February last year, I joined BlueSP as an APM engineer. And since joining BlueSP, I've worked on various projects in predictive maintenance and multivariate analytics in the mining, metals, and mineral space, as well as oil and gas and petrochemical. So our presenters for today, first up we have Raiza, who is an APM engineer at BlueSP. She joined early this year and hit the ground running with a predictive maintenance project for a mining giant. She has previous experience in the steelmaking industry, and she holds a chemical engineering degree from Stellenbosch University. Next, we have Koos du Toit. He's a senior APM engineer and APM leader for BlueSP. Koos is an electrical engineer and an accredited system architect with over 20 years experience in the industrial automation space. Prior to joining BlueSP, Koos was a solution architect at Schneider Electric for the mining, metals, and minerals pillar, where he led and managed professional services in automation projects across the EMEA region. He has also worked in petrochemicals, oil and gas, and food and beverage in the early years of his career. He is currently the APM team leader at BlueSP, and since joining, he has worked on numerous projects for clients in mining and metals to improve their maintenance strategies with prescriptive maintenance, as well as conducted multivariate analysis studies to understand quality and yield for leading metal producers. Last but not least, we have John Campbell, our Mtell product manager from Aspen Technology. John is the Mtell product manager and has worked at Aspentech for over 23 years. He started at Aspentech in the Advanced Process Control Services group after completing his PhD at the University of Wisconsin in the area of time variant estimation for use in model predictive control. John worked in services, support, and development of advanced process control, otherwise known as APC, in these products before taking a position running the development group. He next moved into APC product management, and after years of steady product growth and the release of DMC3, Aspen's premier control offering, John then took on a new challenge. This new challenge was a product management position in a strategy and planning role. This move came at a time when Aspentech was pivoting to provide solutions in reliability and maintenance. After Aspen acquired multiple APM companies and formed the new APM business unit, John then jumped back into solution product management by taking on the Mtell role. So first on the agenda today, John will take us through why, what, and how condition monitoring with AspenMtell and the key capabilities of the solution, including Maestro agents. Next, Koos will deliver a deeper session into the data that AspenMtell uses in terms of identifying sensors for predictions, data quality, and correlation analysis, with some examples of where Mtell has been used and applied on various assets in industry. Raiza will then give us a practical view of Mtell and how it performs predictions with its unique machine learning methodology. Finally, John will show us some exciting new features being developed for the future generation of Mtell. We will then close with a Q&A session, so please direct any questions you have in the chat beforehand so that we can address them at the end. Over to you, John.
Okay, I think I have shared and I have audio. So first let me say what a great opportunity this is to get together with all of you today. We've enjoyed putting this together for you, and I think we have some really good material for you to talk about today. I will put up our disclaimer as I talk about things that are not released. It's just be aware that it's not a indication that it will be released, just making sure I'm keeping my legal people happy. So back to this this picture that Wilhelm talked about a little bit. I do want to tell you a little bit about how the Asset Performance Management Suite at Aspentech came about. It was about 4 or 5 years ago that our CEO was talking to other C-level people in his travels to talk to our customers, and they really agreed that our design software, our simulation software, fit their needs, and our operate software is increasing their ability to to throughput, better quality. And they said, but you know, we lose it all when our equipment breaks. And it just kept coming up. And so Antonio Pietre, our CEO, started saying, well, what can we do about that? Why don't we look at the complete asset lifecycle instead of just designing and operating? And out of that, the asset performance management suite was the seed of that was born, and we started acquiring companies. We acquired Mtell, we acquired Fidelis, we acquired ProMV. These are all companies that have made up our asset performance management suite. So let's zero in a little bit on Mtell today. I'm going to go through the why, the how, and the what of Mtell, and then what's kind of neat about this presentation is that I have kind of the Aspentech point of view, and then you're going to get to also hear some of the from the field point of view from Riza and Kuz. So it's a good mix here. Of course, there was an APM webinar a few weeks ago, and the objectives of APM and changing the way you're doing reliability and maintenance is clear. You know, people want to increase the asset availability. They have important objectives around reducing emissions and increasing safety. These things are forefront of every company, right? And so with the surge in digitization funding, people are looking to solve these problems and improve these metrics. One thing we do know is that reliability-centered maintenance, where you're trying to schedule your maintenance, hits about 18% of the failures. 82% of them are process induced. Okay, so what Mtell is going to do is target these, because we're going to use the process as information in order to predict failures and help you change the way you think about things. So there's a big opportunity here. We know that. Just an example of how important it is about the environment. This is a very interesting information about a plant, and this was sulfur dioxide released. You can see how much was released throughout the year in 2015, how much in 2016, and then how much in one single day in 2017. It was more than the previous 2 years combined, and that's because emissions and safety are not linear things. They happen when there's disruptions to the plant. And so if there was any kind of warning that they were going to have the downtime or the that caused this incident, it's the kind of thing that can be avoided. So that's pretty dramatic. That's also, we know that if you're starting up your plant or shutting down your plant, that's when the accidents happen. 5 times more often, accidents occur during those times of operation. And so being able to completely stop a shutdown or being able to plan for it better allows all of your personnel to plan better, to be ready, and to not have to make snap decisions and stuff. And that's when accidents happen. So basically, we're saying, what if we knew that we could turn unplanned downtime into planned downtime? This helps all of the groups around the manufacturing site, the planning, the planners, the schedulers, production, what feedstocks are being ordered. If you know that things are going to change, sales, inventory, and maintenance. Everybody can be impacted. And in addition to Mtell's idea that we're going to help you turn unplanned downtime into planned downtime, we have another product at Aspentech called Fidelis, which is for risk management. It's not the focus of today, so I'm gonna point you at a video on our website. It's a 5-minute video. It's very well done, and it tells you about a failure of a piece of equipment and how these 4 different groups come together and what they can do about it, because they know about it in advance. So if you just Google Aspentech Decision Agility, you'll find that little movie. We have some good movies on our website. So
I'll
let's
also
move
put
into
it in the published area, John. I'll just post it in the published area for us. Carry on.
Okay, thank you. Okay, so the what. Let's talk a little bit about what Mtell is trying to do. Now we know the classic problem failure curve, and that at some point, you know, the sensors are going to give a good indication that something is going wrong. But that is usually after damage has happened, after you can't really do too much about it. So what we want to do, oh, I went backwards, stand by. So what you really want to do is get some more lead time on that particular failure. Okay, so the much earlier detection, there are patterns in the data that machine learning can detect. Okay, and so we can detect these specific failures, and I keep going backwards. And maybe the farther back we go, the more lead time you have, the better off you are in your planning and etc. So we've worked on our technology is largely industry and equipment agnostic. If you have a set of sensors and some past failures, we can give you an agent, we call them, that will help predict when future failures happen. So you can here's some just examples across the various industries that we've worked in. Okay, so now let's go in a little bit into the how. Okay, so this is it's very much a project mentality when you're putting together an Mtell solution. Okay, so you need the past sensor and failure history. So we're going to go and look at your historian. We're going to go look at your EAM system, and we're going to pull that information together. What's important to realize about Mtell is you don't need to be a data scientist to use it. In fact, the people who are most successful with it are those who understand the processes that they're working on. Okay, so looking back at that failure history and understanding what happened at those different times, very valuable piece of information. We don't need high frequency data in many of the industries that we've been looking at. Sometimes, typically we would take hourly data and look at it over 2, 3, 5 years, depending on when the failures were. So hourly data is sufficient for getting lead times of 20 to 40 days. Okay, and then we have to, of course, with any kind of data science solution, you're going to be cleaning up the data a little bit. So you're going to look at where you think the data is valid and where it's invalid. And then we're going to train the agents to learn what normal behavior is for this piece of equipment, and also build failure agents on that equipment. You deploy these agents online because now that you have some kind of pattern-based model that can predict things, you want to predict them in the future. So we deploy them online. They run at the same schedule that you designed them. So maybe they run hourly. And then they alert when they see things that are out of the ordinary. You can take those alerts then and using, we have online tools. We have a web server right now, and I'll talk some more about how we want to move in the future on this. But you give the alerts to the right people, and then they can decide, do we need to go out and check the equipment? Do we need to go check our model? Where's our next steps? Is it time to start planning for this piece of equipment to fail? And if so, what can we do to actually prevent it from failing? If we're running the process in such a way as that it's causing the problem, then let's stop running the process in that manner. So those are how you turn unplanned downtime into no downtime. There's also so we also have anomaly agents. When you don't have a lot of failure information about your various pieces of equipment, we will build anomaly agents. And anomaly agents are used by the engineer to say, okay, this is normal behavior in this section, this is abnormal behavior, and it learns that, and it'll alert you when it sees abnormal behavior, which may be an indication that some failure is coming, or you're operating in a different manner. So both of those things are valuable pieces of information. And so we kind of have a project methodology there, and we follow best practices around that. But let's talk a little bit about how do these failures manifest themselves? How do I understand the data that Mtell is using? And so we turn all these sensors into a probability waveform. Between 0 and 1, that's the probability of a failure or anomaly occurring. Somewhere above 50.5, we start to alert. Okay, so that's basically what we do. So what do we do with this to get the data? Well, there are certain, if I'm looking at 2 years of your data, there may be a bunch of data in when the equipment was offline. I'm going to remove that data. There may be known failures, and I'll put those into my in my calculus here, and they have a pre-failure and a post-failure interval, and I can figure out what it is specifically about those failures. there may be failures that we don't know about, but they're in the data for sure. And so we have something called a hidden failure agent that will figure out those. And then what's left after that is really pretty much the normal behavior. And so with all these different patterns, we can create different agents for different purposes, and altogether we get a total solution. So I like to emphasize here, this is something that Google published about, a lot of the machine learning techniques, the machine learning code it's open source. It's out there, you can grab it. And but when you look at a real world machine learning system, there's really a lot more than just the machine learning code. Okay, you can see all these different boxes around here. I talked a little bit about, we have to do data collection, we have to do data verification, we have to extract the features that we're going to use to show that what the patterns are around. So there's this rich set of processes and tools that are around the machine learning code. And so kind of one of the things that I want to point out about Mtell is it is a very sophisticated and complete solution. So we have ways of getting the data from the various systems. We manage the hierarchy because you may have a lot of assets and you need to manage all of that. You're going to have different tools for building the agents, anomaly agents, hidden failure agents, and Maestro agents, which I'll talk about in a little bit. You can build calculated sensors to supplement your sensors, and then there's this whole online alert lifecycle management that is really important too. To me, I think that what Aspentech is providing here is kind of a total solution. There's lots of complicated stuff on the inside, but you can use the tool to do what you want to do, which is to predict the failures. With that, I'm going to turn it over to Kuz to talk a little bit about what's in the data, and we'll get a more hands-on perspective here.
Thanks a lot, John. Good day, everybody. So yes, basically, when we look at our data every day, from an engineering point of view and so forth, and we try to figure out what is going on in the data, we tend to struggle. Our eyes can only see 2 dimensions, and our brains interpret this to allow us to observe 3D, right? If we look at the graphs on the right, it's easy if you look at a sensor, for instance, and the history regarding a sensor. You can quickly interpret what's going on. If you add another sensor, you can still make it out what's happening. But as soon as you start adding on more, it becomes difficult to visualize, and also mentally to sort of see how everything fits together and how behaviors change. It just becomes very difficult, and we struggle to do that. So we basically struggle to recognize cause and effect over more than a couple of seconds, and that really doesn't help us a lot. So we've got tools, we've got univariate tools, and we have multivariate analysis tools to help us to understand the sense of behavior better. And we have historians that's got strong functionalities, and that helps us to understand our equipment and the associated sensors are behaving real time. And we have this information so we can drill into specific events. And because there are so many sensors, we tend to put thresholds in place to allow us, our control system, to start and stop equipment and so forth, and to alert us when these thresholds are exceeded. But unfortunately, many of our failures occur while our sensors are in with these threshold bounds. So therefore, we've got condition monitoring systems, and they allow us to monitor specific conditions of an asset, right? But they commonly use Boolean rules to determine the health of an asset, and many of these CBM systems also make use of thresholds. So on Mtell, we basically have a functionality, the standard comprehensive CBM environment, where we can create rule-based agents. However, Mtell, as mentioned before, we've got anomaly and machine learning agents, and Mtell considers your asset management system data. It only doesn't look at the process data. It looks at your work orders and breakdowns and so forth. So Mtell helps us to make sense of all this data, sensor data, through a probability waveform, And that's a single point trend amalgamated from all your incoming data streams, right? Sorry. And this single trend basically represents the probability of failure for an asset over a time period, basically, that we train that data on. So this puts all this data that we cannot comprehend in multidimensionals of data into a single trend that we can analyze and understand. Okay, next slide, please. So when we start looking at the sensors that we need inside Mtell, if you look on the right-hand side, so with each asset, you basically, there's a couple of characteristics associated with it, and we try to represent it with sensors, and that's not always available. But your asset performs a certain function, so therefore it will have a certain behavior, and there's also a health aspect associated with this asset. And if we can capture that health aspect, we know what the condition of our asset is and when it's going to fail and is it healthy. Now, when we look at our sensors on a plant, we don't always have a luxury to have every single aspect or form of energy that we have sensorized. It's just not practical and it's too expensive. But what helps us a lot is that in a process, we know that upstream and downstream, we are also measuring different things through sensors, and with all of these, through the transfer of energy, they've got an effect either on our asset or our asset's behavior will be reflected in these other sensors. So we can use these sensors together with our physical sensors that's associated with the asset. So, and that helps us a lot. So even in cases where our customers have a situation where they either decommission a specific instrument on plant, so it won't be available, or through technical issues that sensor data become available, that is not a problem because we do not only zoom in on one sensor. We look at the combination of sensors and how they behave over a period of time. So even if we do lose a sensor, we can still predict failures and detect anomalies. So practically, we should have at least 4 or 5 sensors that we have surrounding an asset so that we can be effective. And the lead time will basically increase. So we can have a lead time detected with these 4 or 5 sensors. But if we have more sensors associated with an asset, that will typically increase the lead time that we have available to warn of impending failures. And then the other thing is also that in some, we might have a strategy on a plant where we focus on our priority assets and we would install sensors to look at the behavior of these sensors, but we cannot do it for all the assets on a plant. So Mtell has transfer learning capabilities. So if we've got an asset train inside Mtell with its various sensors, that behavior of how the system and the sensors interact can be captured and we can transfer it onto another asset, even if that asset doesn't, and that's a similar asset. For instance, 2 similar pumps, similar nameplate ratings, we can transfer learn what we've learned on pump A onto pump B, even if pump B doesn't have those exact same sensors, and we'll still be able to do prediction with that. So that's a very strong point of Mtell. And next slide, please. So when we get this data now on site and we push it into Mtell, we've got various functionalities that assist us in making sure that the data that we use, that it is clean, as John mentioned before. So first of all, we've got after we've did our configuration for our equipment set or asset, its associated sensors, we can pull a sensor audit report that will quickly show us in our historians and in our other data sources, what is the condition of each of those sensors. And then we also have a SPC trend functionality. So once we've established that certain of our sensors might not have frequent data, or that there's transient outliers and so forth, even that the values become stagnant and flatline over time, We can look at the SPC trends and look at the overall behavior of that sensor over a period of time and still see, is it a valuable sensor value that we can use? Are there periods that we need to take cognizance of the fact that the sensor might have been offline, etc. But we can quickly understand how each sensor behaves. And then there's a further functionality, the quick correlation analysis. So once again, if you've got 40 sensors associated with an asset, it's very difficult for you to figure out how are these sensors correlated? How do they behave together in a certain events and so forth? And the quick correlation analysis will quickly help us to see where do we have strong correlation between the sensors, and it helps us to identify sensor groups as well. So you have pre-configured sensor functionalities. We try to group the sensors into these sensor groups so that when we train agents, they can quickly detect faults that's relevant to a specific area, like for instance, a hydraulic power pack, or on a compressor, your intercoolers, and so forth. You can separate it. You don't look at the compressor as one piece of equipment. You can break it into the sub-functionalities and associate the sensors regarding that. Build anomaly agents also on these functions so that when it alerts, you've got a good and clear direction of what is currently failing. And then the more automated part, which John will speak about a bit later, is on Maestro. So I'm not going to discuss Maestro now. But so all these tools help us to get the data into Mtell, to trust the data that we're basically working with, to identify the sensor groups. Also, as he's mentioned before, the frequency of data. So we would typically start with an hourly frequency of data, but we might find for specific equipment based on their behavior, they might start and stop much more frequently. So we need to have a higher resolution, and we can quickly accommodate that as well. And then we look at, once we've done our SPC trends and our evaluation, we can quickly determine from that, together with our associated work orders information that we have, where do we need to start focusing on to determine what the normal behavior of that asset is, so that we can zoom in on that. And then at the end of the day, it's to understand basically with the associated work orders, where is the probable cause of our failures? So that when we train failure agents, what makes the strong differentiator with failure agents is not the fact that it just tells you that something is going to go wrong. It's going to tell you exactly what is going to fail, so that you can quickly be able to analyze and investigate that specific failure. And then also associated with that is the associated workflow, which will also guide people and teams in terms of what is the corrective measures to take to prevent these failures, to rectify the situation, and also capture that knowledge. Next slide. So all of us in the mining, I'm showing mining because that's most of our customer base and it's a strong focus for us. So this is just a summary of various assets that we've done in mining. And as you can see, this is both it's surface operations and even haulage trucks and so forth, underground operations and conveyors and etc. And also the distinction between mining and the physical process plant. So we cover all of that. And then it's also, you'll see there's a mix between, though Mtell is very strong on rotating assets, we can also definitely do fixed asset. Anything that's got a sensor, a couple of sensors on it, can be used. So it's not strictly focused only surrounding rotating equipment, and therefore there's transformers and all these things on here as well. So quite a good mix in mining, and we've done this on quite a number of these assets. That's me.
Okay, thank you, Koos. Thank you everyone for joining us. I'm going to take you a bit under the AspenMtell bonnet. Okay, so let's dive into it. I'm going to quickly touch on the data aggregation capability of AspenMtell once more. So AspenMtell takes your process and mechanical sensor data, so your seasonal changes, batches, startups, shutdowns, etc., and it aggregates it into a single trend. So like John said, the probability waveform. This probability waveform shows you basically the probability of failure at every single point in time. Okay, next, I just want to give you a refresher of the agent training process. So what the wizard does is it separates the chart into 4 categories. So the first one is offline. So this is when your equipment is shut down. And next is the failure category. So this is where changes of behavior lead up to a recorded event. Then we leave out some data as holdout data. This is used to test your agents that you build. It's used to test its accuracy. And then we have the unexpected. So these are changes in behavior that are not linked to a failure event, but which are monitored by hidden failure agents to watch for the specific patterns. And then whatever is left after removing your known failures, offline conditions, and hidden failures is your purest form of normal. So then the wizard creates an anomaly agent, and this is used to accurately detect and alert to any changes from normal behavior. And then you have your failure agent, which is then created, where we use a training period incorporating some normal and the failure signature. And then finally, that holdout data that you left out at the beginning, that is what you will now use to test the accuracy of your failure agent. Okay, so let's take a look next at the AspenMtell autonomous agent methodology. Let's start with the anomaly agent. So what the anomaly agent does is it first reads the sensor data, transforms it, performs pattern recognition, and then when it detects an unknown anomaly, it will send an alert requesting an inspection to determine the cause of it. So this is where operations will intervene, and they can either find that all is fine and it's just perhaps a new operating state, in which case by simply checking a tick box, they can select an additional operating state, or they could find that this is a never seen before failure. In the case of a new failure pattern, action then requires that a failure agent be created to prevent future breakdowns. Okay, next, let's take a look at the failure agent. So the failure agent, like the anomaly agent, it will read the data, transform it, performs pattern recognition, and then when a known failure signature is detected, it will alert to the impending equipment failure, and then it will start your maintenance workflow. And this is where then your operations will intervene. Okay, next up, I am going to show you 2 case studies and trying to demonstrate to you the predictive power of the tool. So first up is a bearing failure, which occurred due to a power disruption. So when the system started up again, this lubrication oil pump did not come back online, and the turbine generator continued to run without lubrication for about 8 to 10 days, at which point the bearing seized and caused significant damage to the entire machine. So as you can see here, this anomaly agent was able to see the small change in behavior, and it could have alerted to the lubrication system malfunction. Then we had a failure agent which was created, and this was created based on the anomaly detection. This was part of a proof of value exercise, and it was done offline. But as you can see, it clearly shows the ability to identify critical failures and safety incidents. Next up, let's look at, so you have here your agent performance metrics. So this gives you an indication of how is your agent performing. So you can see that this failure agent was proven to be 80% accurate, 0 false positives, and it had given a whopping 8-day lead time. Okay, next, I'm going to take your attention to the bottom right of this slide, where we have the sensor prediction rank. So on your sensor prediction rank, you can see the top contributing sensors to failure, which actually aids you in your troubleshooting. And then if you look on the sensor trend, you will see that according to your sensor prediction rank, those sensors actually show some deviation from normal. And this catch could have resulted in enormous savings in terms of repair costs and the electricity production loss. Okay, next I'm going to show you how Mtell was able to detect minute changes. So this case study deals with an oil filter blockage on a ball mill trunnion lubrication system. So these clients experienced 3 oil filter blockages within a space of 4 months. So you can see there was a failure agent that was created, this showing the probability waveform here, and it picked up, so this agent was trained on 2 failure signatures, and it effortlessly picked up the third. If you look at the top, these are the lead times that were given. And with lead times like this, it then allows for better planning, spares procurement, better utilization of resources, and so forth. And here you have your sensor prediction rank. So this is what I really wanted to show you guys. So you see at the top here, it is an input pressure that was our top contributing sensor. And you really, really have to strain your eyes if you look at the sensor trend to see that it picked up these very, very small increases and hence alerted to that failure. And lastly, I'm going to talk about the agent performance metrics for the failure agent that I've just shown you. And this gives you an indication of how your agent is performing in terms of accuracy, precision, false positives, etc. For the filter blockage failure agent, a 88.3% overall accuracy was achieved and 0 overall false positives, meaning no false alerts and no unnecessary panic. And with that, I now hand you back to John.
Okay. Let me properly share here again.
We're seeing it, John.
Oh, okay. Okay, good. Is it not showing? Something was funny here. Let me try again. There we go. Is that better?
Thanks, we see it. Yep.
Okay, so both Kuz and Riza said some interesting things that I want to that kind of motivate why we came up with something called the Maestro agents. Maestro agents are failure agents, and I like to describe them as they're using machine learning techniques in order to generate a machine learning agent. Okay, so we're going to help the user during the process of picking out the sensors and picking out the data. I think Kuz made a good point that there's energy in some of the sensors that are upstream of the equipment that you're looking at. I think a lot of the equipment manufacturers that give you some kind of monitoring around their pieces of equipment are experts at modeling and looking at their piece of equipment, but a lot of times what's happening upstream is what the problem is. An example I can think of is a compressor that is there's a problem with liquid carryover. Well, the liquid carryover you can detect in an upstream column. Okay, so that's just one example of using. So, but how do you know which sensors to use? Okay, so this is where Maestro comes in. Maestro is the technology that helps users select and prepare data for agent building. It helps you with the feature engineering. So which sensors and which data am I going to use? And it allows you in some of the ways that we're using it to incorporate some domain knowledge. We're actually using it, for example, with windmills and with oil well blockages out in the oil fields. So, you know, there's some ways for us to incorporate some additional information into that. So, you know, what we like to say about Mtell's, our most successful projects that we do is when Aspentech or one of our integration partners does, you know, about 60% of the work, and the client does about 40% of the work. And why do we say that? Well, because first of all, they know about the processes, they learn how to build the Mtell agents, and then they're able they're left with the solution that they're able to maintain and use. And so, you know, we value that information, but you still have to do some picking out of sensors and stuff. So this is where we're trying to help you with Maestro. So I like this slide because this kind of shows you the Mtell workflow, where you might select a sensor group and select the events to train against, train your agent, and then you're going to evaluate the performance of that agent. You'll look at the probability waveform, and you'll look at the events you have, and you'll see if it predicted them with a sufficient lead time and no false positives and all that kind of good stuff. You may find, well, I need to maybe change what I'm doing. Maybe I need to add some sensors. Maybe I've put too many correlated sensors in. I need to do some stuff around that. So what we're trying to do is with Maestro is move that into the automation part that the engine is doing. So it looks at the various candidate events, it looks at the candidate sensors that you've provided, and it'll train the agent and it'll iterate around that. So it's kind of a neat technology. We found that it's useful in a variety of circumstances, and here's just some industry examples where we've had some success with it. It's relatively new. It was released in November of last year. So, and then the next thing I want to talk about is just a couple, endorsements from some of successes from some of the companies. What I like about this one is this is a relatively large rollout of 250 assets across 12 refineries and 6 pipelines. So it's a pretty big, it's an enterprise scale solution. And this is one of the companies that was training the people at each site. So they have lots of people throughout their enterprise now that know how to interpret and use and build more agents. They're all building agents. So they've had a couple big successes. One of them was on a pipeline pump, and they know that when that goes down and they have some kind of spill, that's a $35 million mistake. So being able to prevent that. Some of these are, you can make the maintenance cheaper. Some of these are, you save on production, right? And almost, you have to look at both sides of the coin there. They also detected a high lube oil supply pressure that was causing an oil leakage on a compressor motor, and they can react to that before it became really bad, and that was another big savings. And then anomaly agents also working on a hydrogen makeup compressor, and inspect it predicted basically a ring leak. Now, I think Riza covered this, but I'll reinforce this. When you get an anomaly to alert or a failure to alert, we give you the sensor rankings that contributed to that alert. So in the case of an anomaly, we don't know what the failure is, right? This is just abnormal behavior, but you can follow the trail. So you look at the sensors that are behaving abnormally, and you get your process people to look at that, and they have a clue of where to start, and then they can figure out what the problem is. In this case, they found the leak. Another example is for a mining customer, and so we have again, we're doing multiple sites here. So we're doing an enterprise level solution. So we had a couple. The nice quote there, we're writing history here. Early warning of discharge conveyor gearbox failure. So that was part of a $3 million in benefits identified at one site. Conveyor rate exceeded historical levels and risk damage. So that alerted them to go look into that, and they were able to prevent further damage to the equipment. And then there was one on vibration in the gearbox. And what I'll say about that is, again, the vibration itself is not just caused by the piece of equipment, but also by what's happening upstream. So the condition monitoring equipment on that gearbox itself did not detect this, but Mtell did. So those are some success stories, and I want to talk a little bit about the managing of alerts. Okay, so once you get an alert, if you don't manage it correctly, get it in front of the right people and make sure that it's addressed. It's kind of like, running the ball up to the goal line, but not scoring, right? So what you want to do is make sure that you're getting your money's worth out of these insights. We bought a company last July called Sabisu, and it has a visualization and workflow tool, which we have rebranded Aspen Enterprise Insights, and so it's used for surfacing insights for your data. And we realized that this might be a very good front end for the APM products that we have for their online parts. So what APM Insights is our new idea of an integrated online workflow and visualization tool for Mtell, ProMV, Fidelis, and Event Analytics, which are products that we have or are considering releasing. So APM Insights, it integrates with other Aspentech suites. So eventually we'll be able to impact the manufacturing and engineering suites by sharing information on the glass for our customers. That's concepts like digital twin and another one that makes sense is if we know that you're operating the plant in a way that is damaging equipment, well, let's let the manufacturing software, the APC, the GDOT, the planning, the scheduling, let's let that software know that that's happening so that we can control that better. Excuse me a minute. Okay, so some of the opportunities we have is to manage the maintenance strategy. Just 1 minute. I cannot get my phone to stop. There we go. Okay, so Mtell View is our web server that allows you to manage alerts, but we see opportunities beyond that. So if we can manage the maintenance strategy, okay, so if we can use these alerts to drive into workflows that's going to let the right people know about the maintenance that needs to be done, then we start to optimize that. That's a really neat idea. Can we do threat mitigation analysis? Can we do continuous threat mitigation? So there's all sorts of ideas around the maintenance strategy that can come forth when we illuminate this information and put it in front of the right people. Improve operations. That's what I was talking about before. When you realize that you're running the process upset is running is caused by a certain past behavior, can we stop that past behavior, okay, in the future? And then of course there's huge communication value. We would like to be able to better show the value of the various alerts that are going off, because as people are building these agents, they need to propagate that around their company, and so that makes it easier for them to say, look, the solution is working, here's the places it's worked, here's the money we've saved, right? So those are all good things. So it has a very strong visualization component to it, so it's going to look a little nicer than very modern, and that's helpful. It has context. We'd like to be able to put information through pictures. People respond well to understanding if they could see the piece of equipment, more like a digital twin type idea. There's good aggregation. So if you want to look at your assets across a site, across an enterprise, across an area that you're responsible for, that can be done. Great collaboration because of these workflows, and then it's extensible so that you can add your own information into this Insights product. So we're excited about that. We don't have a release date for it, but it does make sense that we're shortly to be in beta, and so if you're interested in that, you could contact me. It would go well with a current Mtell solution that you're using. With that, I'll hand it back to Kanish to maybe wind up with some questions here.
Yes, thank you, John. That was very insightful for all of us. So I have a couple of questions here in the chat. Maybe I'll give you one that's probably good for you to answer. We have a question here where someone's asked, do the agents work on batch processes where the process is repeated perhaps every hour and there are transition zones, which is probably as important as the steady state periods?
So yes, we can work on, so there's a couple things I would say about batch. First, we have as Mtell is designed to predict when equipment is going to fail, ProMV is our product that is predicting how operations is doing. Are you meeting quality? And it has a very strong batch component. So you can compare batch to batch to batch to see if you're on track producing the quality you want. That's not about equipment failure, but that is about operating better. So we have lots of batch technology around that. With regards to Mtell, you would remove the offline data and you would look at the rest of it. I think Maestro might be a little stronger on detecting failures for that. It aggregates the data a little bit better. So yes, we do work on batch systems.
Okay, great. And I believe there's also a good use case in pharmaceuticals where a lot of the processes are batch type, and Mtell has been applied there. So we can send you some of that information as well. Okay, and then yeah, we have another question. I'll direct this one to Raiza. So someone's asked, how does Mtell create probability waveform from multiple trend data? Does it make one waveform for each sensor data or one waveform for each equipment?
Thanks, Kinesh. So what it does is it takes all your sensor data that are associated with a certain piece of equipment, and it agglomerates that into a single probability waveform.
Okay, great. And then maybe one more question for you, Koos. So someone is asked, how works the anomaly agent? What is behind this AI? Is it AI based? Is Mtell supervised based? And what about failures that the agent didn't learn from past events? What about the results? And how can an operator understand the result given by the software?
Okay, it's a lot of questions.
Maybe just start about the anomaly
let's-
agent and
Yeah, let's just see. I'm just quickly reading here. Okay, yes, all. So where is first? Sorry, just give me that question again.
okay. So the
Oh, here
first
we
part of
go.
the question.
Here we go. All right. So the anomaly agent, basically, you can. Just want to read. Sorry, give me a second because there's 3 questions or 2 questions. Didn't learn from what? Tell us about the failures agents didn't learn from the past. So yeah, Mtell is supervised based, but okay. So the failures that we didn't learn from the past, that depends basically on the period of training that we select. So we need to have the associated work order information with the historical piece of data associated with it to be able to train. Otherwise, we've got no idea if it's normal or abnormal behavior. So we have to, if we don't know the failures, we cannot train on that specific portion. And then, so the process for basically, I just want to understand, is it, how does it, okay, so what is behind? So anomalies use unsupervised learning techniques, okay? Such as clustering to identify patterns which are multivariate correlations of data, okay? And it begins, we collect all the data from various collection streams into the Mtell builder, and then through proprietary techniques, we basically create that waveform. So if you wanted to know specifically why, we can send you more detail. It is not AI based, it's machine learning. And it's not machine learning on its own, so we refer to it as like bots. So basically it's a combination of machine learning. And once again, it's not just straight model based agents. And we combine, the very important thing is we combine our work order information with it to understand what's the context of what we're looking at.
I would just add that if a failure agent triggers, the operator can know this failure agent was built on this type of failure. You're headed for that type of failure. So that's a good piece of information. If it's an anomaly agent, what we do is we give you the sensor ranks, and both Raiza and I talked about that. So they might, I'm not sure if an operator would look at that sensor, the top ranked sensor, and say, oh, I know what's going on, or if they would maybe consult with their process engineers or their maintenance engineers and say, hey, let's figure this out together, because this sensor is high, it's not normally this high, what's going on? And so it's with anomaly agents is a series of clues. The rest of Koos's answer about the machine learning was spot on.
Ganesh, maybe a last question for John.
Sure. So we have a question from Filiberto, who's sort of given us an explanation of they've experienced a failure in the past for 2 different conditions in causes. And some of the challenges they have is related to finding the correct data or amount of data. And the second is to find the correct sampling of the data in order to create a sustainable and accurate prediction. And how do they deal with these problems, especially when the degradation over time is quite critical? So how would you answer him?
Okay, so I said earlier that we typically use 1 hour data. Sometimes we use 30-minute data. I've seen us use 15-minute data. So I don't see in the vast number of projects that we've done that people have to really work hard to figure out what frequency to use. It seems like in general that level of data is pretty good. So that frequency. So that's what I would say about the frequency. The other part of that was is it the data? Was it about the data quality? I've lost my.
It was the sampling and the amount of data.
Yeah, the amount of data. So for anomaly agents, we would use 15 to 18 months of data. If you could find good swaths of normal. For failures, we just go back until we get the number of failures we want, 2 or 3, if we can do that. Sometimes you have to put 5 years of data in there just to get you know, a couple failures. So that's kind of some rules of thumb, if you will.
And maybe just the last part of the question, what kind of preparation is needed by customers to maintain this kind of technology? So we've seen that it's, you know, it's easy for Aspentech or a partner to kind of implement the solutions for them, but what do they need to run with it?
And so their day-to-day use of it is going to be through looking at the web page and processing the alerts. Either when you get an alert on an anomaly agent, you may decide that you're operating normally, and so you retrain that agent. There's a way to retrain it from the web page. If it's not an agent, if it's not normal behavior, then you need to process that alert and get the right people involved. That's probably number one thing people will be doing. The reason we like to get our customers involved in the building of agents is so that when they decide that they see a new failure and they want to build a new agent, or they have another piece of equipment that they're like, it's time to add this some protection around this piece of equipment, that they can do it themselves. So there's an offline part, kind of the building part, and then there's the online managing part. Both of those are important.
Okay, great. So I think we've just hit 5 minutes past the hour. Vulalem?
Yeah, thanks, John, and thanks, you know, Koos, Rahesh, and also Raisha, and also Ganesh for preparing. But yeah, John, it's quite early that they're your side, so you've got a whole day ahead of you. We'll let you go, but thanks for the information. And then, for everybody that basically spent the hour with us, we really appreciate the time that you did spend with us. And I know that we didn't answer all the questions, so please, you keep on typing, texting. What we will do is we get a whole list of all the questions. We'll come back to you via email or via a phone call in the next 24 hours or so. So, so sorry if we didn't answer your specific question, directly. Also, as you can see on the screen, so this event is recorded, so you can refer back to it. Tomorrow morning you could share it with a colleague, and go through the content again, because we dealt with quite a lot of information in this specific event. And then at any time you will receive an email from us tomorrow. But you can at any time basically just email us back and say, listen, I want to speak to one of your business consultants in more detail about Mtell and what we're doing. Like I said, I texted in the team. Our team knows this technology very, very well. We've implemented it at some of the largest mining clients in Africa, in Southern Africa, in the last 6 months. A lot of that work was also done during the lockdown. So really, we've also proven to ourselves that we can remotely, work on these technologies and work on this site. And really, you basically pick data up from historian level, and then you bring the value to that. And so this is like I said, this is part of an 11-week webinar series that we are in. So please, refer back to the previous 2 sessions on APM, the multivariate analysis, and also the specific initial one on Mtell. And yeah, there is, like John also mentioned, the Aspen Enterprise Insight in this one. Well, last week there was a very, very good session specifically on that, if you want to see that live, because we did a lot of live demos there on that specific technology set. And then, as you can see, the roadshow, the webinar show carries on. So come back next week, same time. The next 2 weeks, we're focusing deeper in MES technologies. So going into things like metal accounting, mass balancing, delay accounting, downtime solutions. So higher order reporting, ERO reporting associated with MES. We're finishing off this series with simulation, with the simulation engineering technology guys on the 5th of August. So, so register for these events, and you can, as I said, you can go back to any one of the previous ones in the series, and also refer back to that. And then the last one is we're still continuing, it is lockdown, so, our training center is closed in the office, but you can at any time register for e-learning or for virtual training. So we are regularly still doing virtual training on all the technology set, be it advanced process control or MES or APM functionality, or even some of the design tools like HYSYS. So just contact Amanda Strauss and the team, and they will be in contact with you associated with our online training or our virtual training. Yeah, and like I said, respond to that email that you'll get tomorrow morning about this recording if you want us to contact you further, and we will also scan through your questions and come back to you within the next day or two if we didn't answer your specific question. Thanks again for your commitment and engagement. We really appreciate you taking the hour out of your busy schedule and being with us on this call. Until we see you next week, Wednesday, I'm going to sign off right now. Thanks.